I'm over here in my stock room, and what I'm doing is I'm contemplating the induction system for Emily's 340. We happen to be building it and trying to get ahead of the curve a little bit on the intake manifold and carburetor. And you can see I've got a few choices in here, and I have a few dilemmas too. And I'm going to explain the whole situation and what I'm thinking about for a remedy. Now, I've created my own problem here, you know. I'm a self-enabler because I really didn't have a problem. All I have to do is get a manifold and put a carburetor on it, but I want to run the thermoquad. And as you can see, it's got huge secondaries, 2 1/4 inch and 1 1/2 inch primaries. So it takes a special carburetor flange, like the the regular Performer, I should say, the standard Performer as I call it, it's built to take the thermoquad. So that's a simple choice. I could put that on, but this really isn't that high performance of a manifold, and I'm kind of thinking it might hold it back. So the alternatives are pretty slim because most Edelbrock manifolds are designed for a 4150 flange, which is exemplified by this Holley carburetor. This is a really large one. It's 1000 HP. It's got big barrels and flows 1000 CFM. It's a full race carburetor. I obviously wouldn't use this. It wouldn't be the correct choice. The correct choice would be some 4150 Holley style carburetor and this. This is the Performer RPM air gap. This with the Holley carburetor always makes the best power curve for a street style engine application. It's a 2-plane design, which means you have an upper plenum and a lower plenum separated by a divider. So I can get into all the minutia, but let's just get to the bottom line. It makes more torque, and this thing also keeps up in the horsepower department. So what do I do? Do I put a thermoquad on here? Well, you can't. There's not enough meat in here for the thermoquad pattern. Here we have the thermoquad gasket. Number one, there's no place for the bolt holes to go because the thermoquad has a narrower bolt pattern than the Holley. And also, right here, we're falling off the edge. Basically, I can see daylight right in this corner and right there as well, see? So that would take welding modifications, and there's no place for the bolt hole. It's just not practical. And I don't want to run an adapter because it adds over 1 inch of extra height. So what I wanted to do is find a manifold that'll offer pretty good performance and yet be able to take the thermoquad without an adapter. Well, I kind of found the candidate right here. This is the Wyand Accelerator. See, look, it says right there, Accelerator. This thing, we ran it in the Engine Masters magazine of old on a 360, and it made phenomenal torque for a single plane, and it made outstanding horsepower. And best of all, taking my thermoquad pattern here, there's plenty of meat, as you can see by the outline here, to open this up for the secondaries. And it also has the bosses already for the narrower bolt pattern. It's not drilled or tapped, but that would be a modification I would make. So what I'm going to do is port that plenum out so I can run the thermoquad, drill and tap it, and then I'll have this ready to bolt on. And I'll test this, and those modifications will not exclude the possibility of putting a regular Holley pattern 4150, which is a way more common carburetor, and we can do a comparison test. So that's going to be a very versatile piece for me to use. I might even try the regular standard Performer. It comes with 3/18 size runners, but they just neck down where they meet the head. And if you go in and do a deep port match, this manifold might not be too bad. So the long runners and the dual plane might give me an advantage in torque. I don't know how much horsepower I'm going to give up. On like a 480 horsepower small block, it's 25 horsepower down the drain putting that on, which is a lot to give up. But maybe with the port match, it'll be better. So this guy will probably run as well when we dyno the motor, so we can see the baseline top dog combination, the Edelbrock Performer RPM air gap with a Holley carburetor, and we'll see how well we do with our Mongrel intake manifold with the junkyard thermoquad. And last but not least, I found another intake manifold that would take a modification for a thermoquad. This is the old Edelbrock Street Master, and it is just absolutely a train wreck. It's the horror. The horror. They put this clover pattern here apparently just to restrict the intake plenum for no apparent reason. And then they put tiny runners that I can't even get my finger into the port. So if you've got a poor flowing head and you want to make it worse, just grab yourself a Street Master at the swap meet, bolt it on, and you're good to go. So that's the whole intake manifold situation. I'm going to get to work with a little bit of grinding. I'll show you how I'm going to lay it out. I'll show you the tools I'm going to use and get this thing hogged out to take the mighty thermoquad. I can't wait. I don't know why I love thermoquads so much. I guess it's because they're so good. Anyhow, take this somewhere where I won't make too much of a mess and begin porting. Okay, it's time for the nitty gritty, and that's going to begin with taking this template, which is actually a hard gasket, an OEM one for a thermoquad, and kind of laying out the whole shape of it onto this manifold flange. I've already had a preliminary look at it, and normally you would have the bolts for the thermoquad pattern in line with the 4150 bolt pattern, but looking at how much material I've got at the front and back of the flange, I would be pretty thin at the front, so I'm going to have to cheat it a little bit back as far as the bolt holes. So step one here, marking for the bolt hole location, and instead of going to the center line of the existing bolt holes, I'm going to go to the back edge of it. And it'll be right there, and then I'll repeat that right here. What that'll do is it'll offset it by just 1/2 of a bolt hole. So that sets me forward and back as far as my drill location, and side to side, I'm just going to eyeball using the existing bolt holes as reference. So you'll want to look straight down on it so that you don't have any parallax error as you're looking. And okay, that looks pretty good. All right, and voila! I've got this thing pretty well marked, and I've got a full 1/4 of an inch of flange left at the front, which is what you'll find with the purpose-built thermoquad manifold. So a minor relocation of about 3/16 of an inch rearward took care of that problem. I've got everything outlined. It looks symmetrical. I've got about the same amount of meat on both sides of the secondary, and I've located the bolt holes fore and aft. The last step is going to be placing this here, and then marking the lateral position, effectively creating a crosshair or a bullseye. So, make sure I'm lined up to my marks there. Perfect. Righto, now I'm going to go to my grinding rack, and I'm going to use an air die grinder and some carbide porting burrs. And with that, I'm going to be thermoquad ready. Yeah. I'm all set up. Now this is my whole apparatus for grinding, and You must be as impressed as I am, because I've got this special rack. This is for porting. I do heads on this. I do intake manifolds. It's very flexible. It's a good working height for standing up. And also I can hang my tools like ear nozzle for blowing out the chips. My grinders, I can actually put 4 grinders on it. This allows me to clamp a stop so the workpiece is secure. I've got an aluminum burr. I have a lubricant. You need a lubricant when grinding aluminum because the aluminum will stick to your tool, and that's an uncomfortable feeling. Take it from me. So, I'm all set, and I'm going to commence grinding. One final step I'm going to take before I walk away from this is I'm going to take my Dichem layout glue and I'm going to glue this area that I was cutting, and then I'm just going to give it a final brush off with the grinder. That's going to show me any high or low spots or bad transitions. With the layout die on it, you can really see the layout. So you might notice the placement of the carburetor, just moving it forward a tiny bit, gave me just the perfect amount of meat front and back, and side to side I've got plenty of meat. So this pad will accept the thermoquad base with these modifications really, really nicely. I've got no question about that, giving me a very good seal at the base of the carburetor. That's really good. So, as you're able to see, the layout glue gives you a pretty good guide, and get that really smooth. What I'm doing is I'm locating the bolt hole positions using this thermoquad base plate as my guide, because it's going to be exactly right, because that's what I want to put on a thermoquad. I've already located the position of the plate exactly where I want it, and I used one transfer punch and punched the hole. That puts it right in the center of the existing bolt hole, and got that one finished, so that gives me a relative position. It'll pivot either direction, clockwise or counterclockwise from there. So I'm just going to assure myself that it's centered up. Okay, that looks pretty good. So, get another transfer punch, stick it in the hole. Using a big sledge because I want to be deliberate, make a nice punch mark. All punched, and time to move over to the drill press. I have my intake manifold set on the drill press, and there's one mistake you could make if you don't think of it ahead of time, but the carburetor flange is often at a different angle compared to the intake manifold itself. So right now, I've got the table set at 0, it's dead level. But if I take this and put it up here, the bubble arrow is telling me that it's not even close. So luckily this table's adjustable for angles, so I'm gonna just go down here. I've got a wrench. Okay, that's good. You might notice I put a little tape on the drill bit. That's so I kind of know when I'm deep enough and I can be consistent on all the bolt holes. All right, go time. Okay, drilling all done. Take this over, run the tap through it, and this manifold will be ready for thermoquad. I'm ready to tap. Little trick, I've got a nut screwed onto the tap, and that's going to help me feel when it's square. Okay, it's all done. Well, there's one more thing. Get the bolt on the mighty thermoquad. That's the moment I've been waiting for. I'll go grab it. Remember I said I was done? Well, I wasn't quite done because I just wanted to smooth out my modifications a little bit. So I took this crosscut burr, it's carbide of course, and just gave it a really nice finish. There's no reason to go any finer than that. You don't have to take out the Tootsie Rolls. That's just not going to be a very active area anyway. So, with that completed, I gave the thing a little bit of a hose down to clean it up. And now I'm going to demonstrate the thing with this filthy thermoquad sitting on top. The key is to get all the bolts to line up. I've got the first one started, I think. Now normally you would have a really thick gasket between the thermoquad and the intake manifold, but I left that out because the thick gasket's going to give it a little bit of extra clearance of the butterflies hitting the wall of the intake. So by omitting that, I'm giving it a worst case scenario clearance test. Oh, one other step that I took that I didn't show before is I went and chased every one of the bolt holes with a bottoming tap. What that tap is it doesn't have the point on it, which will bottom in the hole, and it's tapered so you don't get threads all the way to the bottom. And the bottoming tap is squared off on the end, and that gives you threads right to the bottom of the hole. So, there it is, bolted on. The bolt pattern fits the carburetor perfectly, and I can demonstrate the throttle opening. All done. So now the only thing we have left to do is select the actual thermoquad that's going to accompany this manifold on the 340 engine build. And once we get that selected, it's going to be time to rebuild the thermoquad.